Hi, everyone. Welcome back to this session on data visualization and image processing. The next talk will be given by Nicolas Kruchten from Plotly. He will be talking about Plotly Express and Dash. At the end of the session, we'll have 5 minutes for Q&A, so you can type your questions in the Q&A tab in the chat. So, Nicolas, the floor is yours.
Thanks very much. Hi, everyone. My name is Nicolas Kruchten from Plotly, and as Emma said, I'm here to talk to you about Plotly Express and Dash. Data visualization, it's no secret, is a core part of data science, both early on in most data science projects, sort of irrespective of domain. Data visualization is used for data exploration, for exploratory data analysis, and in the later stages of a project, again, basically no matter the domain, data visualization is critical in communication of results, explanation of the process, and in operationalization of whatever the output of the data science project is. The interesting thing to me is that data visualization is used a little bit differently in both of these stages. So early on in a project, we tend to want to make many interactive graphics quickly to get a sense of the data, build a mental model of it, check our expectations about the data against our mental model, look for patterns, look for outliers, and to validate data quality. When we're working with data visualization at the last mile, we tend to be working in a bit of a different mode. We'll make fewer graphics, more polished graphics, maybe for publications in articles, perhaps as a PDF, or on the web. We'll want to make graphics that interact with each other or interact with various controls to allow non-data scientists to interact with whatever it is that we've built. And we're ultimately hoping to make whatever models we're putting together actionable for non-data scientists. So the two Python libraries that I'll be talking to you about today kind of fit reasonably neatly into these two categories, which is why I've titled my talk this way. So the first library is called Plotly Express, and it's a library designed to essentially make graphics in a single function call and make it easy to quickly iterate through various visual forms, while at the same time providing a good basis to make an easy to tailor graphic for publication or for communication sort of downstream. And it fits neatly into the other library, which I'll be talking about today. It's sort of a 2-for-1, which is Dash. Dash is a framework to make web applications that link together graphics, controls, and text. Dash allows you to make applications where you can control every aspect of the layout and styling. And the resulting application is sort of just a Flask application. So it's reasonably easy to deploy. You can host it somewhere on Heroku, which is a cheap hosting platform, or most cloud hosting platforms have ways of hosting Flask applications. Both of these libraries are totally free, available offline. You don't need to sign up or sign in to use them. They're both MIT licensed. And Plotly Express is actually part of the larger Plotly package. It's sort of a submodule, plotly.express. So with that, I'm going to switch over to some live coding. So wish me luck. Some of this code is available at github.com/nicholaskruchten/SciPy 2021, and I'll be uploading whatever I live code. I'll try and sort of transcribe and update this repo. So to sort of get going, I'm going to start by walking you through a bit of a contrived example of what a data exploration session might look like using Plotly Express. So we'll start by importing Plotly Express. We tend to call it PX for short. And the data set I'll be using here is one of our demo data sets, px.data.gapminder. It's a tidy data frame. It's very small, just a couple thousand rows. And it essentially has one row per country per year, along with a couple of extra columns like life expectancy, population, GDP per capita, essentially World Bank indicators. I'll be focusing on just a single year. So year equals 2007. And I'll make a note here that although I'm using a pandas data frame here, Plotly Express is actually compatible with a wide variety of different types of inputs, such as NumPy arrays, X arrays, basic iterables, and so on. So to do some basic data exploration, let's look at life expectancy. So to do this, we basically start with, let's make a strip plot. So we'll pass it our data frame, and we'll map life expectancy to the x-axis.
Nick, sorry to interrupt. There's a request if you can increase the size of your font. Can you increase
sorry about that. Is that better?
Thank you.
All right.
I think so. Yeah.
So we're making a strip plot here by mapping life expectancy to the x-axis. So the plot comes up, it's interactive, I can hover over the different data points, I can see the lowest life expectancy is unfortunately 39 years old, 39 years, and I can zoom, but that's about it. Not all that useful for data exploration just yet. Let's see, can we make it so that I can actually identify these points? I can actually give a name to each of these points to appear on hover. And now I can actually see that unfortunately, Swaziland is the country that had the lowest life expectancy in 2007, and Japan is the highest. So interactivity is sort of starting to help. What else can we do? Well, we can use other variables like color. So let's map color to continent here. We can start to see a bit of a breakout here, where you can see, Europe tends to have higher life expectancy, and most of the low life expectancy countries tend to be in sub-Saharan Africa. So this is an okay way of visualizing sort of the distribution of a single variable. Maybe a more standard way of doing that would be a histogram. So let's just switch to the histogram function instead of the strip function, and all of the other parameters sort of just work. And here we go. We've got a stacked histogram by continent. One thing I wanted to mention here is that this legend is interactive as well. I can hide a series. I can bring it back. I can focus just on a single series by double-clicking. Double-clicking brings everything back. I've lost the ability to see individual countries here. When I hover, I'm hovering and I'm seeing the count for a given bin. I can bring that back by adding a marginal plot. Gets a little short, but okay. And I can hover over the marginals, and I get back my hover name here. One thing that I don't love about a histogram in this case is that each country counts for one, right? The y-axis here is count. It's a little bit strange. Very large countries like China and India count for the same as a country like Swaziland. So I'm going to add a variable to the y-axis here, population. And automatically, Plotly Express now is summing for me. It's changed the label here. It's changed the label here, and you can see these two big spikes in Asia for India and China, and you can actually go find them here. So this is an interesting way of viewing this data. If I don't like the stacking, I can actually make a faceted plot here by adding the facet call argument. Now I have a set of charts, small multiples. These will actually zoom together now. When I zoom in on one, they all zoom. Double click to zoom out. Okay, what's a slightly different way that I could look at this data? Let's shuffle it up here. Instead of grouping countries together into single bars, let's make a stacked bar chart. So I'm going to use the bar function. I'm going to map life expectancy to color, X to population, Y to continent, and we'll drop the marginals here. All right, so now same data, same three variables, right? Continent, population, life expectancy, totally different presentation. I've got a stacked bar chart, 1 bar per continent. Each of these little bars here represents a country, so I can actually sort of see what's going on. I can see that China has slightly higher life expectancy than India, and they're both sort of giant countries in Asia. So this is kind of neat, just by shuffling around a couple of keyword arguments and the name of a function. A kind of different perspective on this data would be to say that it's actually a part-to-whole relationship. Let me actually make this a little bit bigger. A part-to-whole relationship where every person in the world lives in a country, and every country is in a continent. So I'm going to use what's called a sunburst diagram to sort of show this nested structure. So again, I'll change the function that I'm using. I'll change this to sunburst. I'll keep color as life expectancy. The sunburst doesn't have X or Y, however, so I'll have to map this to values and this to path, and I'll say continent, country. And here I have a nice sunburst diagram, which is showing this sort of the nested representation of, India is a country in Asia. I can click on Asia, just see Asia. I can click on Asia again to zoom back out. This is kind of a neat way of sort of showing the nesting. You can also see, Japan is right next here, right next to Asia here, and you can see the sort of color contrast between the very high life expectancy of Japan and the sort of middle of the road life expectancy of Asia in general. And then Afghanistan, unfortunately, is here quite lower. So this is one way of showing sort of tree-like structures. A slightly different way of doing this would be with a tree map. Same set of arguments, except here I'm doing nested boxes instead of wrapping things around radially. It's interesting that the word tree map has the word map in it. because obviously each of these little boxes here is a country, so I can actually make a real map. Let's make what's called a choropleth. Again, color is life expectancy. Unfortunately, it's hard to represent two variables in a choropleth, so we'll drop population for now, and we'll pass it a locations variable with these handy ISO codes that I have in my data frame. And so now I've got a map, and you can see essentially again that most of the countries with low life expectancy are clustered in sub-Saharan Africa, most likely due to the AIDS crisis in that part of the world. So that's it for sort of univariate exploration. What if, as I'm doing this, I've sort of formed a perhaps not too radical hypothesis that health is related to wealth, and I want to sort of look at the relationship between life expectancy and GDP per capita. A classic way to do that would be with a scatter plot. I'll put my dependent variable on the y-axis here, and I'll say x is GDP per cap. And not too surprisingly, I see a monotonic relationship roughly between wealth and health. Let's make this a little more attractive. Let's bring color back. Let's bring population back. Okay, these circles are a little small, so let's make them a bit bigger, and let's try and straighten out the curve. So size max equals 60. Log x equals true. And okay, this is kind of a classic scatter plot popularized by Hans Rosling in his TED Talk, and is sort of why we call this dataset the Gapminder dataset after the organization that he founded. So here, you've got little circles for each country, and you can kind of see the monotonic relationship. You can see some outliers down here, countries that have reasonably high GDP per capita, but were impacted by the AIDS crisis. So this might be a reasonable endpoint for a data exploration session where I've pivoted through a bunch of different visual representations of my data. Essentially still with the one function call. Maybe I haven't paid all that much attention to the way things look. I'm using the default colors. The Plotly colors might not be to your taste. All of the automatic labeling here is actually direct labeling from my data frame. So obviously, to do anything else, to put it in a PowerPoint presentation or a journal article, you might need to clean it up. The good news is that you don't have to leave Plotly Express to do that. The objects that Plotly Express returns to you are these Plotly figure objects, which are essentially just large dictionaries full of attributes. You can look at these dictionaries in JupyterLab by calling show JSON and sort of drill through and see all of the different little attributes. And you can actually update these attributes to control basically anything about the figure. So at that point, we're moving out of sort of modifying the one little cell. To save you the watching me typing this, I'll switch over to a sort of canned chart that I've already styled here. So this is the same chart. You see the same bones here. This is the same function that I've called, but it's been styled, fairly differently. I've got a nice title here, Health versus Wealth, 2007. I've sort of customized my axes. I put dollar signs here. The dollar signs show up inside the hover label. I've labeled everything nicely, and I've added a vertical and horizontal line for the mean population weighted mean life expectancy and GDP per capita for the world. I've also moved my legend. I've made it horizontal, and I've sort of dropped the colors and stuff. So how have I done this? This is a mix of two different things. One, I've passed a number of arguments to Plotly Express itself. So I've told it use a simple white template, use this particular discrete color sequence, please use these labels. And then the resulting figure object exposes a number of update methods, like update layout, where I can control my legend, update x-axes, y-axes, I can add h-lines and v-lines and so on. And one other little thing I snuck into the bottom of this cell here is I've actually exported this to an image along the way with write image. So now I have an SVG of this that's not interactive. I have an HTML file, which is interactive, and I have actually got the JSON saved to disk. So if I go over here, I can see I've got an SVG ready for embedding into some sort of document, although this is not interactive. I've got an HTML file. I have to hit the Trust HTML button to view it, but I can upload this to any web server, and this is still interactive. And I've got sort of a nice safe copy of my JSON on disk that I can bring back to edit further. So that's basically as far as Plotly Express will take you for the first mile of data science, and part way down the last mile in terms of styling things. But before I move on to showing you Dash, I did want to sort of hedge my bets a little bit and point out that although I've mostly showed you statistical graphics, with scatters and bars, that's not all Plotly Express can do. Plotly Express works with a variety of data types and other visual forms. So for example, you can pass it gridded data and it will happily make you heat maps. You can pass it data that's more sort of appropriately viewed in a polar plot. For multivariate data exploration, you can make parallel coordinate plots where you can sort of cross-filter various variables, all again in a single function call. You can do the same thing for categorical variables. Two more, you can make ternary plots if you happen to have only 3 variables. And if they don't sum up to 100, you can use 3D plots as well. So all of these are just a single function call away with plotly.express. Now switching sort of over to the last mile part of my talk, it turns out that much of the time you need actually more than one chart to make the point that you're making. And maybe you want them to interact with each other. Maybe you need to wrap a set of controls around your charts to allow your users or your readers to kind of drill in a little bit deeper into the insights that you've come up with in your data science projects. And that's where Dash comes in. So Dash is a framework, like I've said, for making interactive web applications that are sort of data heavy and link together graphics and controls. So again, Dash is not a single function call, a little bit like styling a PX chart. So I'm going to switch over into copy-pasted code so you don't have to watch me stumble through a whole bunch of typing. So let me grab some code that I've pre-typed here, paste it into a notebook cell. I run it, I get a little window. I can dock it. Okay, so you've seen a couple of these, I'm sure today, where you've got the code on one side and the app on the other. So this is a very simple Dash app, probably the simplest Dash app that shows all the bits and pieces. I've got a little hello world heading here and a text box, and I can say, hello SciPy 2021. Whatever I type in the box shows up in the header here. The way this works, and this is the basic structure of a Dash application. After I've imported all the things I need, created my application, I've got 2 things. I've got what we call the layout, which is a tree of components. In this case, there's a mixture of HTML components and what we call Dash core components for the input. So I've got these 2 components. And then I've got what we call a callback, which is a function that sort of binds components to each other. So in this case, I'm saying that the value of the input is bound to the children of the output via this string interpolation. And so every time I type a keystroke here, this Python function is evaluated and Dash sort of wires everything together. So that's the basic structure of a Dash application. Doesn't have much to do with graphics yet. Let me tie this back to what I was talking about earlier. So I'm going to show you essentially the same application, except this time, instead of a text box and a header, I'm going to have a dropdown and a graph. So here now I've got a dropdown for the year for my data set, and every time I do anything with it, it updates my graph. How have I done this? Well, okay, I added an extra import for Plotly Express. And in my layout, I now have a dropdown and a graph. And my callback, instead of binding the value of the year the value of the text input to the header, binds the value of the year dropdown to the figure property of the graph. And what's it doing? I mean, it's doing essentially what I showed you a second ago. It's filtering down the data frame and then returning the Plotly Express object, which gets rendered straight away. So that's one step further. I'll take this app one step further, and I'll add another graph. This time I'll make it a map. Sorry, this doesn't all fit in one screen, but okay. So here now I've got a map and I've got a chart. And when I make a selection in my chart, that selection is reflected in my map. So if I choose the sort of less healthy, less wealthy countries, you can see that it's a cluster of countries in sub-Saharan Africa. If I choose the healthy, wealthy countries, you basically get the OECD. How is this all wired up? Basically, all I've done here is I've added one more component to my layout and another callback. This callback is a little bit different. It has 2 inputs. It depends on the year dropdown because, of course, I can still manipulate this. And it also depends on the selected data property of the original graph. So again, it's just narrowing down the selection. Does a little bit of bookkeeping with custom data for the indexes of the data frame here, and then returns px.scattergeo, which is another one of the Plotly Express functions that I didn't show you. So this is essentially the basic structure of a Dash app, and you can kind of mix and match these and grow an application about as large as you like, as I'm about to show you. But all of these applications essentially have the same structure, where there's a layout that shows sort of what goes where, and a set of callbacks that shows how these components interact with each other. So this is the part of the presentation where I do the draw two circles, then draw the rest of the owl, and I leap over a huge amount of complexity. But in the interest of time, I wanted to show you sort of where Dash can go and where Dash has gone. I wanted to show you 3 Dash applications. Like, this is Dash apps for science. So these are not applications that I built or that anyone at Plotly built. These are sort of in the wild. Scientists using Dash for scientific communication, which I think is excellent. The first one is this one. It's estimated cost of electricity and reliability for power systems in sub-Saharan Africa. So this is published by a group at Berkeley. And they've said here, this tool is intended for researchers, infrastructure planners, and off-grid systems designers. So they have a model for calculating various things about cost of power, and they have wrapped a Dash app around this model. So here you see a number of widgets that allow you to control the model and then some of the output. So I'm going to choose a representative load profile, and right away this little graph here updates. I click Update Map. It thinks about it for a while. The map will change in a second. The map will change. And if I make a selection, say the Congo here, you'll see that this heat map down here changes as well. So I'm not really an expert in this domain, but I do think that this is a lovely app, and I really find this as a perfect example of how folks are using Dash to sort of make it possible for non-scientists and non-data scientists to use the output of their work. One thing you'll note about this app is it's not that styled. I mean, it's lovely, it's functional, but it doesn't exactly scream design. The second app I wanted to show you is this CRISPR in Delphi app. Oops, sorry. Which I have already opened in a tab here. So this is sort of the next level up in terms of styling and control. This entire website here is a Dash application, including the user guide, including this little sidebar and everything. And the authors here say, this website provides an online interactive implementation of in Delphi, a computational model that predicts DNA repair outcomes for some specific situations, which I'm not really up to the details. What I like about this is it's got a kind of a batch mode where you get a DNA string. You can set a bunch of options around the model. You hit predict, a little bit similar to the previous app. Sort of there's a Python model running in the background here. And then the output is a nice set of plotly graphs, all very interactive. You can click here. It takes you to a single mode where you can drill in a little bit deeper into the results. And this app has all the bells and whistles. There's a shareable link to your results. You can sort of see how it compares to other things. You can control these sliders. You can download the summary statistics. In a very real way, to me, this is actually part of the future of scientific publishing. We won't be making PDFs. This won't be an app in support of a PDF. This will be the publication, or so I hope. And we at Plotly are really excited about Dash being a part of that. And so kudos to the authors of this application. The final application that I wanted to show folks here actually comes from Springer Nature Labs. So it's not only folks who are publishing in journals who are working with Dash, but it's actually journal makers themselves. So in this case, Springer Nature has put together an explorer for papers about computational social science. So this site here is in fact a Dash app as well. It's got some interesting bar charts about a bunch of statistics about articles in this domain. It's got some word clouds. Some links to various things, and at the bottom, I kind of like this. It has a social network analysis of communities of researchers and what they're working on. And so you can sort of drag around, zoom into this network, click on something, it thinks about it a little bit, and it'll tell you how many researchers there are in this community and what they're working on. And then there's a social network visualization here. You can sort of drill in and see the co-publications, click on a particular researcher, get information about them. And you can even search for them in this table down here. So that's another example of sort of a Dash app being used in a scientific domain, although perhaps not data science in this case. So that's basically what I wanted to show folks. If you're interested in getting started, and hopefully this presentation has sort of whetted your appetite a little bit, please do. We built this for you, and here's a bunch of links to get you started. So plotly.express is the website for Plotly Express, dash.plotly.com. The gallery here, dash-gallery.plotly.host, has about 100 different Dash applications categorized by domain. And I really encourage you to check out our community forum, which where people ask and answer each other's questions. And there's a beautiful show and tell section where folks are sharing Dash app components that they've built, Dash apps that they've built, and it's really inspiring to see what folks are doing with Dash. So I encourage you to check it out. At the bottom here, I've got a little link for the repo for my talk. Maybe someone can paste it in the conversation. It's github.com/nicholascrushton/SciPy 2021, where you'll get some of the code. And then when the video is up on YouTube, I'll link to it as well from the repo. I thank you very much for listening. If you are interested in any of my work, my personal website is nicholas.crushton.com. You can follow me on Twitter, and then obviously Plotly, plotly.com and @plotlygraphs on Twitter. I believe I've left a little bit of time for questions. If folks have questions,
Yes.
I'm happy to answer.
Thank you, Nick. Thank you for a great talk. You saw a lot of enthusiasm and emojis during the talk, and you have actually a lot of questions. So would you like me to read them, or would you rather go to the Q&A tab, sort them by upvotes?
Yeah, let me do that. So I'm in Q&A here, sort by...
So if you can read the question and then answer it.
Yeah, for sure. Okay, so the most upvoted question is, what are the advantages and disadvantages of Plotly Express and Dash as compared to Holoviz? Okay, this is obviously a question I've anticipated. It's a little bit hard for me to answer. You know, I'm an expert in Dash and Plotly Express, and I wouldn't want to mischaracterize anything about Holoviz. So I would encourage folks curious about that to maybe join the Birds of a Feather session this evening, and maybe you can get some of the Holoviz folks and I talking about it. But I don't think I'd want to kind of provide a side-by-side breakdown right here. The second most upvoted question here is, how do you create different tabs in a Dash app? There is a tab component. So in the layout tree, you can create a tab set, and then there's a little sub layout tree for each tab, and the render method. Sorry, the renderer allows you to switch between them. So tabs are sort of a first-class citizen within Dash. Hopefully that answers the question. The next question is, I've been using the Plotly backend for Pandas. Is it better practice to use PX natively or the Pandas backend? I don't know. I don't think it matters. I mean, the Plotly backend, the Pandas backend, which I didn't show, actually just calls the same function. So it's really, do you want to do df.scatter or do you want to do px.scatter df? It's mostly just a convenience for data scientists that we've done this. This is sort of documented on our doc site, but if you want to use Plotly Express via Pandas, you just set the Pandas backend to be Plotly Express, and then pandas.plot will default to Plotly instead of matplotlib. I don't have a recommendation either way. The next question is, does Dash perform computations in the backend? Yes. So every time you interact with a Dash application, under the hood, an HTTP call gets made to a stateless backend, a Python function is run, and the result of that Python function is sent back to the browser in JSON format. So that is the default mode of operation with @app.callback. But there is also @app.client-side callback, where you can provide a JavaScript fragment if you have some computation that you A, want to write in JavaScript and know how, and B, can be executed on the front end. It is possible to skip that server-side step, essentially as a performance optimization. Let's see here. Related to my questions, there's also about Plotly Go. Curious about the relationship between plotly.graphObjects and plotly.express. So that's an excellent question. So when you pip install Plotly, you get the Plotly Python module, which has a number of submodules, one of which is plotly.express, and the other main one is plotly.graphObjects, which has objects such as figure and scatter and marker. So these two are totally intercompatible. Every time you call px.scatter, say, you get back an object which is defined in the graphObjects package. So when you're using Plotly Express, you are using graphObjects. The relationship I like to kind of pithily say here is, Plotly Express to graphObjects is a little bit like Seaborn to Matplotlib. You call a Seaborn function, you get a Matplotlib object out. You call a Plotly Express function, you get a graphObjects object back out. And so anything you can do in graphObjects, you can do with the output of Plotly Express. Last question here. The event I mentioned that I and the Holoviz creators will attend later today, it's the Birds of a Feather session, which will be in gather.town. I believe there's information about that in the Slack, but I think it's also on the schedule. So it's like this kind of virtual environment where we'll be talking. There'll be a panel, so I'll be there. And James Bednar has invited representatives from various other DataViz libraries and tools in the Python ecosystem. So I really look forward to the conversation.
There was also a question about choropleth, just above.
Oh, sorry. Choropleth requires a column with the names, countries, and the countries are strings. So yeah, choropleth is a bit of a funky function. So you need to pass it a locations column, and then by default there's a built-in map from Natural Earth that is indexed by ISO alpha codes, so 3-letter codes per country. And I think there's also a state map for the US. But you can also provide a GeoJSON object or a GeoPandas data frame, and then you can use the indices from the GeoPandas data frame. So if you just Google Plotly maps GeoJSON, you can land on the documentation for that. I kind of like glossed over that in my demo because I happen to have the ISO codes and I happen to want a world map. But if you want to make, a map of the departments of France or something, you're going to have to provide your own GeoJSON for that.
Okay, great, perfectly on time. So let's give Nick again a round of applause. Thank you very much. And so we'll have a 5-minute break, and after you can join the lightning talk session. And the data visualization and image processing session will be starting again tomorrow. Thank you. We can end the session now.
Thank you so much.